G'day viewers, I'm going to try and see what a mod will do to this NiCad battery. Instead of over-amping it, just cause it to smoke. I want to see what high voltage does to it. And I got another button cell to pop anyway, so this one's a Panasonic CR20253 3V. It is unplugged, so be very careful with MOTs, they are dangerous things. Go that way this time. See how that goes. Do one battery at a time, see what happens. And we'll plug in, our ballast is all set up. Plug it in. Alright, power on. Yeah, about 9 amps to the ballast there. Before I commence that, I put my safety glasses on. Safety first if you're doing popping, so glasses. I won't really bother doing it outside, so it's a bit dusty out there. Let's do it in here. Had a bit of a dust on last night. There we go. I didn't give it enough room, I held it down too hard, so it didn't really get far. That's one battery pop. Unplug safety first. And I'm going to get out of here because that's lithium. Don't feed that stuff in. Okay, there was a fresh air, cleared the whole smoke out. Let's commence this battery. No, I've already got all the smoke out of this one by the looks of it. Try and look at the camera too, because this arc's pretty bright. Arc's sustaining quite well there. There's an arc differently through the battery than it does straight off the mic, so if I go like this, seems to be a bit longer. Yeah. Interesting how the battery makes the arc behave. Come on, stay arcing. The wind gets blowing it away. Okay viewers, let's see if the battery even charged, even the slightest bit. Alright. Plate to the case. 324 millivolts. And there you go. A little bit less than that to begin with. Did actually charge it very clearly, but that was AC not DC, so see what else we can try. Okay, viewers, a quick look in the basic components of this button cell with this little separator which sits inside there. That's like a plate that separates the negative plate from the positive shell. So the positive's the shell, the negative's the end cap, and that black stuff's the material. So it's probably a very minimal amount of lithium in there. There's a little seal around the outside which is all melted to the case. Seals like a plastic seal. There you go. And that would have been in there. Simple, not much to these little batteries. Okay viewers, this is a DIN mount time switch. This was used to control the hot water service. The bottom clip's been broken off unfortunately. That would have sat in your terminal box on with a bunch of circuit breakers, and you pull this little bottom part out. You have a pin that goes in here. The little locking pin comes out, so no one messes with it. That comes out like that. And you got your day, program it, your hours, your, I think that must be when you're away from home for a while, you can set it not to come on at all. So you get your load comes in through here, active and neutral, and these come out to a control to your hot water service heating element. Now I'll open it up before I plug it in and show you what it looks like inside. Made by Glassland in Germany. Tier 240 volt AC, 50 to 60 Hz. 16 amp 250 volt AC relay. So viewers have a high quality printed circuit board. And that's your relay there. 6000 ohm coil, 60 volt to control that coil. 16 amp contacts in that relay. This was taken out of service because the contacts kind of got a bit dirty and it wasn't switching hot water service on all the time. Basically you got a big, it's a film capacitor that looks like an update coupler there, resistor, 2 G18 MPS A39 transistors. This other one is an MPS A43 PH 62 transistor. A Zener, 1 microfarad 100 volt electrolytic, 2 resistors, another Zener, little resistor there, and that's all your charging circuit for your backup battery. Made in Japan, so it's high quality battery. It's just a couple of button cells, about 3 of those, taped up and made into a little battery pack, and that just runs the clock when the power fails. I think it lasts about 3 or 4 months, so this can stay 3 or 4 months at a time without power and keep its program. Back of this display we've got some little things here, surface mount components, and behind that the silicone chip under a blob of plastic behind there, which is what will be the brains of the circuit. So yeah, this is just a membrane going to the display where your buttons on it, which slides out. Time to reassemble and test it. Oh yeah, there's another capacitor under here too, so there really isn't much to this, so let's give it a test and see if we can program it. Okay viewers, it's all rewired, put back together, ready for a test. We should hear a relay click. Okay viewers, had to wait a bit for the battery to charge up for it to turn on. It's on now. I was expecting it to come on straight away, but it's a bit of a delay, so let's try and program this. Very careful not to touch the live connections. It is relatively safe anyway, so just gotta watch it. I will hear the meters not turning, not using any power. Now got to reset it. There's a little reset button here I'm going to press to try and get it to go back into program mode. So reset that. Okay, the relay clicked. That should be ready to program. Got the time there and the days of the week, so numbers 1 to 7. See if I can program this. I think I've got to hold the clock symbol down. H plus, so hour. This is a 24-hour clock, so whatever the time is, might be 11 o'clock, so let's program that. Say it's 11:30 or so. To set it, I don't quite remember how to set it. There's a daylight saving thing here too. Press that, it goes 1 hour. Yeah. I've long lost the instructions to this, so I don't quite remember how to use it. Hold that thing, you gotta hold the clock symbol down or something like that, I can't remember. Day, shows what day of the week comes on. Power's off, the battery's already charged a little bit. It's been a bit hard to use at first, but once you learn how to use it, it's pretty easy. Now in order for this to switch on a load, you have to have active or phase coming in through 5, and that goes through to your load, and neutral comes back in through here. But yeah, I still prefer the old mechanical ones like this. They're much easier to use and much more better made. Thanks for watching.